We're continuing to look at some select homework problems for related rates, chapter 2.6. This is 22, 24, and 26, and they all involve Pythagorean theorem. So 22, construction worker pulls a 5-meter plank up the side of a building under construction by means of a rope tied to one end of the plank. So we see this plank is being pulled up by the worker. Assume the opposite end of the plank follows a path perpendicular to the wall of the building, and the worker pulls the rope at a rate of 0.15 meters per second. How fast is the end of the plank sliding down or sliding along the ground when it is 2.5 meters from the wall of the building? So let's think about what's happening with this plank here. So as the plank is being pulled up, it's also sliding. This end of the plank is sliding along the ground towards the wall. Okay, so we have the plank going up and also moving to the left. Okay, so we see a right triangle here, right? And let's think about what's happening to the length of the vertical and the horizontal length of this triangle as the worker is pulling the plank up. So as the worker is pulling the plank up, we know that this y value is going to be increasing over time. It's going to get taller and taller. So we know dy dt should be a positive rate. But x, dx dt, we know that as the plank is getting pulled up, the plank is also sliding towards the wall, meaning that this x value is going to get smaller over time. So we know dx dt will be a negative value. Okay, so let's see. We know that the rope is being pulled up at a rate of 0.15 meters per second, and we know that the y value is going to be increasing over time, so we can say dy dt is a positive 0.15 meters per second. How fast is the end of the plank? So we're trying to find dx dt at the moment when x is 2.5 meters. So we have a right triangle, so our starting equation is Pythagorean theorem. X squared plus y squared equals hypotenuse squared. Hypotenuse is a constant value of 5, so I should replace the z with 5 squared. So now we can find the derivative with respect to time. So x squared becomes 2x dx dt, y squared becomes 2y dy dt. 5 squared this is basically 25, so it's a constant, so the derivative for a constant will be 0. So let's see what else we need. We're trying to find dx dt, so that's the missing variable that we're trying to solve for. We know x 2.5. We know dy dt, which is 0.15. The one missing information that we still need to find to plug in is this y value. So let's go and look at the dimensions for this triangle. We know x squared plus y squared equals 5 squared. We know at the moment when x is 2.5, we can plug in 2.5 in for x, and from there we can figure out what the y value is at this specific time. So I replace x with 2.5. 2.5 squared plus y squared equals 25. Subtract 2.5 squared from both sides. We get 18.75. Take the square root. We get square root of 18.75. So root 18.75 is the exact value of this y, of this vertical length, at the moment when this horizontal length is 2.5 meters from the wall. So we should have enough information now to plug into our equation. Replace x with 2.5. Okay. Replace dx dt with well, that's the missing variable they're trying to look for. Replace y, we just found that, with root 18.75. Replace dy dt with 0.15. And then the 0 will stay 0 on the other side. So we're going to try and clean this up so we can solve for dx dt. Combine those like terms, move over to the other side, we get negative 1.299. 2 times 2.5 is 5, divide both sides by 5. So dx dt is negative 1.299 divided by 5, or negative 0.26 meters per second. 24, a boat is pulled into a dock by means of a winch 12 feet above the deck of the boat. So here we have a right triangle, and we can think of this as the hypotenuse. So the hypotenuse is going to be decreasing over time. This is the distance between the winch and the water below. So this length is not going to be changing over time. And then we know x will be changing over time since the boat is getting pulled towards the dock, which means that we expect this x to be decreasing over time. Okay, so a couple of things here to keep in mind. So here we have our right triangle. I'm going to let the x represent the horizontal distance. We know this x is going to be changing over time. As the boat is moving, we know this will be changing. The vertical distance, however, is not going to be changing over time, so that will remain a constant. And z will be changing over time, so we let z, which is the length of the rope which is being pulled in, we'll let that hypotenuse be represented by a variable of z. Okay, so now let's look at what information we can gather. Winch is being pulled in at a rate of 4 feet per second, so that we know that the rope is referring to the z variable, at a rate of 4 feet per second, so we know 4 is the rate. However, let's think about what's happening to this rope. This rope is decreasing over time, so it's getting pulled in. We know this length is going to be getting smaller, so we want the rate to represent that as well. So the rate of the rope being pulled in is negative 4 feet per second. Determine the speed of the boat when there is 13 feet of rope out. So we know z is the length of the rope. The moment when z is 13, we want to find dx dt, which is the speed of the boat, or the rate at which the boat is moving towards the dock. And again, we are dealing with Pythagorean theorem, so x squared plus y squared equals z squared. We can replace y with 12 since this value is not changing. It'll remain a constant all the way throughout the problem. So x squared plus 12 squared equals z squared. Let's go ahead and find the derivative. X squared becomes 2x dx dt, going through power rule. 12 squared is a constant, so which is 144. The derivative for 144 is 0. Z squared becomes 2z dz dt. So let's see what information we have. We have dz dt to plug in, which is negative 4. We have z, which is 13. We're trying to find dx dt, so this will remain, we'll have to let this variable stay. The only thing missing is this x. So to find this x, we go back to our diagram. We know that at this specific moment that we're talking about, x is 5. So if I do 5 squared plus 12 squared, I can make that equal to z squared. And from there, we can solve for x, so x equals 5. So now we found x being 5, replace 5 for x, and then we can solve for dx dt. So here we get negative 8 times 13 divided by 10, which comes out to be negative 10.4 feet per second. So speed is positive, so speed is 10.4 feet per second. Or speed is the absolute value of the velocity, so that's why we make that adjustment to make it a positive speed. For part B, it's the same equation, similar scenario, but now we're told that the boat is moving at a constant rate of 4 feet per second, so we know dx dt is represented by 4, but again, we're talking about velocity, and because the rope, or because the distance, this horizontal distance, is decreasing over time, we want to represent that with a negative. Z is 13, x is also 5, but now instead of solving for dx dt, now we're trying to find dz dt, the rate at which the winch is pulling the rope in. So again, same equation, x squared plus 12 squared equals z squared, which comes out to be 2x dx dt is equal to 2z dz dt. We know 5 is x, 13 is z, 0.4 or negative 4, negative 4 is dx dt, and z is 13, so the only missing variable left to solve is dz dt. So 10 times negative 4 is negative 40, divided by 26 comes out to be negative 20 over 13 feet per second. 26, air traffic control. An airplane is flying at an altitude of 5 miles and passes directly over a radar antenna. When the plane is 10 miles away, the radar detects that the distance s is changing at a rate of 240 miles per hour. What's the speed of the plane? So speed of the plane is this horizontal rate of change. So we're trying to find dxdt, and we have a right triangle here that we can use Pythagorean theorem to set up a relationship between the three variables. So x squared plus 5 squared equals s squared. And while we're at it, we can also find the x value at this moment in time, because we know when the plane is 10 miles away, so at this moment when s is 10, we can solve for x. So x squared plus 5 squared equals 10 squared. When we do that, we solve for x squared equals 75, so x equals root 75. Go ahead and find the derivative. X squared becomes 2x dx dt. 5 squared becomes 0. S squared becomes 2s ds dt. We can replace x with root 75. Variable dx dt stays. That's what we're looking for. 10 gets replaced in for s. And then ds dt, we can replace that with the rate of change, the distance from the ground to the plane. So that's 240 miles per hour. So the only missing variable is dx dt. We can cross the 2's out, divide both sides by root 75, and we can get a decimal value or speed of 277.13 miles per hour.